I'm Sloane Greer, and today I'm going to be teaching you about function transformations. The function I use today is f of x is equal to x squared, which is the parent function. And we are going to shift that 3 units to the left and 4 units down. Our new equation is g of x is equal to x plus 3 squared minus 4. The reason we have plus 3 is because whenever you're moving to the left, you're going to use addition, whereas whenever you're shifting to the right, you would use the subtraction sign. And then negative 4 is because we're moving down 4, so it's negative 4, whereas if you were going up 4, it would be plus 4. This is our table for f of x, and the way we get the y values is by plugging the x values into x squared. For g of x, the way we get the y values is plugging in the x values into our new equation, and it gives us these values for y. For our graph, this one is the parent function. We start at the vertex 0, 0, go to the right 1, up 1, to the right 2, up 4, to the left 1, up 1, to the left 2, up 4. The way I usually move it is by I usually move down first and then over to the left or right. So I go down 4, and then I move to the left 3, and then you just do the same pattern. Right 1, up 1, left 1, up 1, right 2, up 4, left 2, up 4. Now we're on to reflections. The parent function is the same, and the new equation is negative x squared. And the reason we do that is because a negative on the inside of the parentheses with x is the same as a reflection over the y-axis, and a negative on the outside of the parentheses means a reflection over the x-axis. The table for f of x has stayed the same. Our new table, we did the same thing as before. We just plug in the x values into the x of our new equation, and that's how we get the new y values. So onto the graph, parent function stayed the same, it's the same parabola. And what I usually do first is I do my reflection over the x-axis first, because I just think it's easier that way. And it's the same pattern, just instead of going up, we go down. So you go to the right 1, down 1 instead of up 1. To the left 1, down 1 instead of up 1. To the left 2, down 4. To the right 2, down 4. And that's how easy it is to do a reflection over the x-axis. And so now for the reflection over the y-axis, it's going to be the same thing, because if you think about it, if you just flip it over the y, it's going to look the exact same since it's a parabola. It's symmetrical. So that's pretty much all we have to do. And then now we're on to vertical compression. Parent function, again, is the same, x squared. And we're going to vertically compress it by 2. So the new equation is 1/2 x squared. And the reason it's 1/2 is because basically when you're compressing, whatever number you're compressing it by, you're going to put that under 1 to make it 1/2. Because if you think about it, you're making it shorter. So f of x is the same as before. G of x, what we're doing to the y values here, basically, I mean, you're still plugging it in, but another way to think of it is you're basically taking half of the y values of the original function. And that's what we're doing for the new equation. And so the way we graph that is by, you basically just look at the points and just follow along. And as you can tell, the black is the parent function and the red is the new function. You can see that it's getting wider because we're compressing it. And you want to note that vertical compression is the same as horizontal stretch. Now we're on to our last transformation. The parent function has stayed the same again, and this time we're vertically stretching it by 2. And so since we're not compressing it, we don't have to put it into a fraction, it's just 2x squared. F of x is the same, and then this time we're multiplying all the y values by 2, as you can see here. So this means that our new parabola is going to be skinnier than the parent function parabola. So again, you just follow along the x and y's, and that's how we plot it on the graph. It's very easy. And then we wanted to note that vertical stretch is the same as horizontal compression. And that's it. Thank you.